The IR port is the infrared control for the OP and system. It is tunable using the handheld remote and can make adjustments to all channels or the channel selected. On the other side of the unit, you'll see there's an IR connector. This is for a connection to an IR wall pad or to an IR hub, which allows for multiple touchpads to be in multiple different rooms. You can then control each channel individually or as a group. This again is RJ45 with Cat5 wire, standard 568B wiring. Let's take a look now at the bottom of the OP. This is the view that will face you if you are looking up past the ceiling grid. You will see here the IR window. This allows you to control the paging level, music, and masking level with the touch of a button of the handheld remote. This is the status indicator. This lets you know that there's power to the unit by an LED flashing. This is the indicator window. This will show you the address of the unit. This is very important to note during installation. You'll notice on the side of the unit there's going to be a sticker, serial number, and an OP number. Each OP is assigned a number from the factory. This is important to note as each OP must be installed in sequence in the order shown on the drawings. The microphone preamp with automatic gain control provides line level output from the microphone to the MPI. This automatic gain control feature maintains consistent paging levels from the preamp to the MPI. This feature also stops pops or hisses found when using standard microphones. 3 gain settings allow for adjustments to the incoming paging level when different types of microphones are used. 3 attack settings allow for changing how quickly the AGC will react, and 3 threshold settings determine what volume level is appropriate for output. This is our microphone preamp with automatic gain control. This is used on any iNet installation that requires a microphone for paging. The automatic gain control feature will stop any popping from the microphone for people that speak too closely to the mic. The functions here are threshold, gain, the attack and release, and your attack time. This helps with how the automatic gain control feature will work with the microphone when speaking. In its simplest definition, the Jordan hub could be considered a breakout box, but for the Spectra iNet system, it has much more functionality. In fact, the multi-drop nature of the system enables messages and data packets to be relayed over Cat5 and travel in any direction, something that competing point-to-point systems can't do. The hub's flexibility and ingenuity results in reduced cable usage and costs while making for a greener installation. For normal installation, the Jordan hub comes pre-wired with connections from pins 1 and 2 to our Ilon on pins 17 and 18. You would then connect an RJ45 Cat5 to one of the outputs in the back to your first OP. The Jordan hub allows for multiple connections to different buildings, different campuses, or different devices. For more information, consult our design team. The local global MPI combination has all of the features and capabilities of a standard MPI, but also has the added functionality that is key to providing mass notification communications across a variety of buildings or locations. The global MPI allows a user to send an all-call page to every connected building at once. This allows real-time communication for company or campus-wide announcements. However, in the case of a localized emergency, the system's tiered paging provides for a top priority emergency microphone page override per station. The unmatched capability of the local global MPI combination allows for crystal clear broadcasts and emergency communications, regardless of whether the facilities are located across the street from each other, across the country, or around the world. The MPI we just reviewed was the standard or local MPI. The MPI here is the global MPI. When used together, they become a very powerful paging tool. The local global system can tie together multiple floors, facilities, or entire campuses to provide a universal communication system that can be accessed locally and globally to ensure that important announcements can be heard whenever and wherever they are needed. Let's get into how they work. For example, the local global here are in building A. There may be a local global in building B. This would connect to your PBX on extension 100. This global would be extension 200. In the other building, your local would be extension 101, but your global would still be extension 200. Each building, building A and B, would have independent building paging through their local MPI on extension 100 and 101. When the entire campus, or both buildings A and B, need to be paged simultaneously, from either building, you can call extension 200. Both globals will light up and send the page out through the entire campus. The wiring connections for the local global are simple. Your ground straps on both units would be connected with a 16.1 or 16.2 wire. They would also connect with a Cat5 RJ45 connection, 568B wiring, between the two units. Only the local would connect to your ILON on pins 17 and 18. Your telephone connections are the standard RJ12 wiring to your PBX. Again, important to remember, this is a POTS appearance line, 48 volts, ring and tip, DTMF, and hang-up supervision. Lencor's Ramp, or Record Audio MPEG player, enables the Spectra iNet system to provide 8 independent, randomly accessible messages through both local and remote control. Messages may be recorded directly to the ramp, expediting the update process in environments where messages change frequently. Continuous playback is available, allowing the operator to leave the application site while broadcasting. If more messaging is required, up to 25 message modules can be added for a total of 58 messages. This ramp also incorporates the latest dynamic message length, DML, technology for increased memory efficiency. Let's get into the ramp. Ramp stands for Record Audio MPEG player. You'll see here you have an indicator for your message, along with the manual controls for recording, selecting your message, and playing or stopping your message. These are your status lights for sync, overdrive, which means too high of an input, the sense of the audio, and your record light. Let's take a look now at the back of the ramp. We're going to start from left to right and talk about the connections. This is your power connection. It's 12 volt with a dedicated plug. It's your RS-232 connector. These config switches are dip switches that allow you to control the front of the unit, whether the record button works or not, and also the number of times each message can play. This is your connection here for relays or a switch box to control the messages either through the phone system in conjunction with our MPI or through a switch box that can be mounted at a security desk or location of your choice. This is your input control should you choose to record messages manually, and your output levels for the output of the audio. The unit comes with removable connectors for ease of installation of your wiring. The Smart Switch revolutionizes MNIC, or Mass Notification Emergency Communication Solutions. It provides total continuity for communication systems, which is critical for MNIC applications and can be done on a global scale. The switch creates a fail-safe for data and audio control, providing infrastructure redundancy for the entire system. The features of the Smart Switch detect and report via email any wire failure or data interruption. Should the paging or data transmission fail, the switch automatically reroutes the data and voice so the system's performance continuity is not affected. The reporting capabilities let the user know when and where a break has occurred for the ease of troubleshooting. The Smart Switch is included in every Spectra iNet MNIC system package. When added to the Spectra iNet system, the Smart Switch can provide total data and audio redundancy. The Smart Switch can detect and report any system compromise by signaling and triggering an email notification. Wiring up a Smart Switch into an iNet system is simple. The data from your last OP would connect here. You would connect the data out from your Jordan hub here. Power can be connected to a 48-volt power supply, the same as your OP. Your indicator lights on the smart switch are power, health, and status. The power is green. Your health, under normal circumstance, normal operating, would be green. If there is a break in the system, the status light will turn red. The Spectra iNet line of products together are a powerful tool for paging, mass notification, music, and sound masking. For more information, visit lencore.com or contact your local sales rep.